Suppose you draw one card from a standard deck of cards. What is the probability of drawing a heart or a king? Can you simply add the probabilities? Sometimes yes, sometimes no. Today you'll learn when to add probabilities, when to subtract the overlap, and one shortcut that can save you lots of time. First, what is a compound event? A compound event is an event formed by combining two or more simple events. Whenever you hear the words like and or, you're dealing with a compound event. For instance, rolling an even number or a number greater than 4 on a die. That would be a compound event. Or drawing a heart and a king. Or passing math or science. These are all examples of compound events. To find the probability that event A or event B occurs, we will use the addition rule. That is, the probability of A union B, that is A or B occurring, would be equal to probability of A plus probability of B minus probability of A intersection B. Why do we subtract, you must ask? If an outcome belongs to both events, it gets counted twice when we add probability of A and probability of B. Subtracting the overlap ensures it's counted only once. For example, one card is drawn from a standard deck of 52 cards. Find the probability of drawing a heart or a king. So first we'll need to find each probability. Probability of drawing a heart, there are 13 hearts in the standard deck of cards, so that will be 13 over 52. And the probability of getting a king will be 4 over 52. Then we need to find the overlap. The king of hearts belong to both. So probability of drawing a heart and a king would be 1 out of 52. Applying the rule, that will be 13 over 52 plus 4 over 52 minus the overlap 1 over 52, and that will be 16 over 52, which simplifies to 4 over 13. Here's another example. A school has 200 students. 80 are in the science club, 60 are in the math club, and 20 are in both. If one student is chosen at random, what is the probability they are in the science club or the math club? So first, we'll find the probability of being in the science club. That will be 80 over 200, which simplifies to 2 over 5. The probability of being in the math club, there are 60 students out of 200 students in the math clubs. That simplifies to 3 over 10. The probability of being in both clubs is 20 over 200, which simplifies to 1 over 10. So in order to find the probability that they are in the science club or in the math club, we'll apply the addition rule. That will be the probability of being in the science club plus the probability of being in the math club minus the probability of being in both clubs. And that will be 80 over 200 plus 60 over 200 minus 20 over 200, which equals 100 over 200, and that will simplify to 3 over 5, which will be the probability that they are in the science club or in the math club. Now let's discuss disjoint, or what we call mutually exclusive events. Two events are disjoint, that is mutually exclusive, if they cannot happen at the same time. So in this case, their overlap would be 0. The probability of A and B would be equal to 0 because they will never happen at the same time. For example, if you roll one die, even A is rolling a 2 and even B is rolling a 5. These events are disjoint because they can never happen at the same time. Since there is no overlap, the probability of rolling a 2 and a 5 would be 0. So therefore, in order to find the probability of A or B in the case of mutually exclusive events, will simply be probability of A plus probability of B. For example, one card is drawn from a standard deck of 52 cards. Find the probability of selecting a 2 or A5. Since a card cannot be both A2 and A5, these events are disjoint. So we'll simply add the probabilities. Probability of getting a 2 is 4 over 52. Probability of getting a 5 is also 4 over 52. That will be equal to 8 over 52, which simplifies to 2 over 13. In this case, there's no overlap to subtract because disjoint events make the addition rule much simpler. Now, the complement of an event consists of all outcomes that are not in the event. Sometimes it's written as A subscript C or A bar or not A. So here's the complement rule. Since we know that the sum of all probabilities must be 1 in a probability distribution, probability of A plus the probability of the complement of A will be equal to 1. You can rewrite this as the probability of the complement of A equals 1 minus the probability of A. Use the complement rule when finding the complement is easier than finding the event itself directly. For example, if fair die is rolled once, find the probability of not rolling a 6. Well, we can find the probability of rolling a 6, which will be 1 over 6. And in order to find the probability of not rolling a 6, we can apply the complement rule. That will be equal to 1 minus 1 over 6, which is 5 over 6. Today you learned 3 probability rules that appear throughout statistics and are among the most frequently tested concepts at the introductory level. Compound events, any event combining 2 or more simple events using and or. The addition rule, add probability of A and probability of B, then subtract the overlap to avoid double counting. And we discussed disjoint and complement rules. Disjoint events simply add, complement subtract from 1. Thanks for watching. Please like, subscribe, and share. And don't forget, math success starts when you stay on the fast track.